So what I want to start doing is showing you how our simplifying that we've done so far is going to lead you to proofs eventually. And so today we're going to do kind of an easier version of the proofs that's really just at its heart is just simplifying, but I want you to start to get used to the way that you're going to write the proofs in here. Okay. First off, I pulled just a geometry proof from a worksheet I used to give when I did teach geometry, just to remind you of what these looked like. How you always started them in geometry is you would take your given and fill it in, and you would write given by your reasons. And then you'd have your algebraic proofs, is where you really started back in geometry, and so you would talk your way through what you did to solve. Now, algebraically, the first thing we could do here, you could either distribute, you could divide. Either way is totally valid, and that's one of the things we're going to talk about as we work through these, when we put these into Trig. So typically, what a geometry student will do is use the distributive. Oopsies, I should be able to spell. Property. And you don't show your work with these, you write your work. So they don't show distributing, they just say, hey, my answer is negative 8x plus 24 equals negative 32. Then in your head, you're thinking, hey, I would subtract this over. Again, you don't show me your work, you tell me it's your subtraction property. And you would actually do it and tell me the answer. So negative 8x equals negative 56. And then, again, you look at this, think how you would solve. You would know that it equals 7. And the reason you know that, apologize, is the division property. So a lot of proofs is switching away from showing me your work. You instead just show me what you get after doing the work, and over to the side telling me why. And the proofs we do here are going to be very similar to that. I'm going to give you a couple structures to organize them a little more easily as you get into these. But again, today's are really just us looking at some simplifying problems and thinking, okay, how would I write that as a proof if I needed to? We're not getting into the complicated proofs here because that's something I would much rather do with you guys together. So when we do a proof in here, first off, what I'm always going to recommend is that you make it, oopsies, come on, really a 3-column proof. I'm trying to shrink it, it's just not working. Oh well. And the reason I do 3 columns, we are going to do all of our work in the middle. And I'm not going to make you write your given, you can just put it at the top of this column. And you're going to have 2 columns for your reasons, one on the left and one on the right. Where this helps, if it's something you did to the left-hand side of the equation, your reason is going to go on the left. If it's something you did to the right-hand side of the equation, your reason is going to go on the right. And what I've picked here for us to start with as our introductions is ones that you're really just going to work on the left-hand side. The right-hand side is really me just giving you the answer like I've done on the paired X so far, where I give you your simplifying and the answer and you tell me how you got there. We're just going to start to put it in a structure that looks like a proof. So, looking only at this left-hand side and what we can do, what I noticed is I have a cosecant. And thinking of all the things we did and we simplified, one of the things was thinking about if you can write everything as sine and cosine. And so cosecant, I can write as 1 over sine of x. And again, that's something you could have done before when we were just simplifying. The only difference here, first off, I'm going to write out the whole equation. And off to the left, I'm going to write why, what I did, how I got from here to here, and what that was our reciprocal identity. So you have to tell me what you did. Then say for the next step, I see some multiplication here, so I'm actually going to do that. It's going to be cosine of x over sine of x. And my reason is just multiplication. You tell me what you did. You don't show me the work, you just tell me it, and that still equals cotangent of x. And then as our last step, this is an identity that we know. That is my quotient identity for cotangent. So I can change cotangent of, or cosine of x over sine x to be cotangent of x. My reason is my quotient property, or quotient identity. And now the left side equals the right side and you are done. Okay, we really didn't do anything different. Last week, the only thing I would have given you would be this information. The new is that you write the other side each time. and now you tell me why. These are things you should have already been thinking through, so this is really just being more specific in your problem. But I'm going to work through a couple more of these. Some I specifically pulled from last time's notes. Like this one here, we did do last time. Again, in the ones I'm giving you here, you are only going to be doing things to the left-hand side of the equation. So if you don't want to write the right-hand column over here, you don't have to. When we get to more complicated proofs, we will be writing the right-hand side as well. So this was, I believe, your second example in your notes before we left for spring break. And if you think back to what we did, again, I'm just going to show you how I would rewrite this one if I'm doing a proof instead of just simple simplifying. The first thing we did was we multiplied out our problem. So you can write multiply, multiplication. I'm good with either. Again, I don't want to see your multiplication. I just want to see the answer to your multiplication. So I would just write out that this is cosine squared plus 2 sine of x, cosine of x, plus sine squared of x, plus, and I'm going to need a second line, so I'm just going to move on down, cosine squared of x minus 2 sine of x, cosine of x, plus sine squared of x, and all of that equals 2. If you need to use your margins or another piece of paper to do that work, that's fine. But again, with proofs, I want you to tell me what you did, not show me what you did. Your work is how you defend it. Then what we did, we saw we had a whole bunch of like terms. So I'm going to add, or addition property, however you want to write it, together everything on the left side. And it's going to give me 2 cosine squared of x. The 2 sine x cosine x minus 2 sine x cosine x cancels. And then I have plus 2 sine squared of x equals 2. Then I notice that I have a GCF here. So I am going to factor out that 2. Factoring will be a big deal as you go through these. And then I hope that you notice by now that this is one of your identities. This is my Pythagorean identity. And so I'm going to replace it. It equals 1. And then last but not least, by multiplication, or multiply, 2 equals 2. So again, we already did this problem last week. The only difference, the nice thing about proofs is you know the answer. It can make it more frustrating if you can't figure out how to get to 2 or get to whatever the answer is, but you do know the answer to these when you're doing these, which really makes them kind of nice to do. Okay, this is another one that we did do in class that I'll just talk you through how I would write this out as a proof. Again, if you want to try it first by yourself, you're more than welcome to do that, and then just listen to me talk about it. So here I have a lot going on, but one of the things I notice is that both the numerator and the denominator are Pythagorean identities. And so I'm going to use that first. As long as you are applying the same identity, you are allowed to do 2 different parts of the problem. So like I can change the top to secant squared of w, and I can change the bottom to cosecant squared of w at the same time because it's the same identity. Then, again, here I'm only working on the left side. What you'll learn when you keep going is you can technically work on the left and right, which can make proofs easier. And if you want to give that a try, you're welcome to. But for now, I'm just going to do things on the left side so it stays like simplifying. But what I noticed is I have my reciprocal identities that I could apply so that I can turn everything into sine and cosine. And then I created for myself here this lovely complex fraction, so I need to deal with that. And how we deal with our complex fractions is we multiply by the LCD. And this is something that if it helps you to write it all the way out, that's totally fine. That's where you can use your margins for, use a scratch piece of paper. But I would be multiplying by sine squared w, cosine squared w on top and bottom, because that is my LCD. On top, the cosine squared w's cancel, and I'm left with just sine squared w. On bottom, the reverse happens, the sine squareds cancel, and I'm left with cosine squared w. That is actually a good thing, because I'm shooting to make this say tangent, and I know from my quotient identity that sine squared over cosine squared is just tangent squared. What you will see with these is the more that you know your identities and the more you've practiced, the easier they will be. So if this is something that you need to work more on simplified as you're looking through things, let me know and I can get you whatever you need to do that. But this really is just more simplifying with a little more writing involved. Okay, one more that we'll try. This one was in the notes, but it's not one that we did. So I wanted to take a second to do it. And again, once you go further, we are going to be allowed to do things to the left and the right. If you feel like brave enough to go ahead and try that, you're welcome to. But I'm going to talk about this just as if we're only working on the left so that it stays like a simplifying problem. So one thing I noticed right off the bat, I have a whole bunch of secants and cosines. And so I want to make them all the same thing. And typically what we do, and this is absolutely up to you, depending upon how you would do the problem, is we use a reciprocal identity. And technically there's two involved here because you could change your cosine or your secant. What I find is most high schoolers will change the secant. So I'm going to talk about it that way. It's not necessarily the way that I would do it, but I want you to see this and I'll talk you through what I would do in a second. Because this does work pretty effectively. And then I have both a complex fraction to simplify and some multiplication to do. You do technically have to do it in two different steps because it's two different reasons. So I could multiply by my LCD first, and it's going to fix just this complex fraction here. When you multiply by cosine of x, first off, remember that denominator is over a 1. When I multiply by cosine, on top they cancel and I just have a 1. On bottom, nothing cancels, it will actually multiply and it's cosine squared of x. And minus 1 over cosine of x times cosine of x. And then I'm going to do my multiplication step. And I'm absolutely okay if you know immediately when this second part multiplies that you just tell me it's 1. And this is when I stop and I look at my identities a little bit and see where I think I'm going. If I want it to be tangent squared, that is a Pythagorean, and that Pythagorean is tangent squared plus 1 equals secant squared. And the nice thing, remember, you are allowed to manipulate your identities. So if we know, again, this is just in the margin, tangent squared of x plus 1 equals secant squared of x, I need tangent alone. So if I solve this equation, it would be secant squared of x minus 1, which is what I'm very, very close to having over here. This is why in the first step, if we go back for a second, I wouldn't have changed everything to cosine because my head was already thinking about this identity and knowing I needed to get it all to be secant. So I, right off the bat, would have changed both cosines to secant and it would shorten it by a step. Now that's not a big deal, but just something to be looking for as you get more and more comfortable. So what I'm going to do, I am going to change this cosine into secant using the reciprocal. And then using my Pythagorean, last but not least, this is tangent squared of x. And those are the same, and so I'm done. Okay, again, everything I'm giving you here is really just a simplifying problem that I'm asking you to write in the structure of a proof so that when we get to that, you'll be much more comfortable with it. This is really just a nice little introduction to see where we're going, and then I will start giving you more complicated ones once we reach that point.